Hello, mathematicians, and welcome back to Mathematical Proofs. Hopefully you watched the first video, and in this video, part 2, we are kicking it up a notch and talking about parallelograms. So, right here, I am instructed that I need to prove that my quadrilateral ABCD is a parallelogram. So I drew it over right over here because that helps me to be able to see what I need to prove and to be able to organize my thoughts. I highly recommend you do that too. Except that this time I'm actually given something. In the last video, we weren't really given anything. So when we are given something, this is usually a hint that we're somehow going to be using this in our proof. So I'm given that the angle BAC is congruent to DCA. So as you can see, I already colored these in as blue to let you guys know and let myself know that these angles are congruent and that BCA and DAC are congruent, and I used the color red for these. So again, in the last video, I kind of covered some important definitions that we might be using. If you need to pause this video, hopefully you wrote them down, but if not, I'm gonna swipe back over to my work. So I'm given that these two angles are congruent and that I need to prove that this shape is a parallelogram. Well, how do we even prove that something is a parallelogram if we can't just draw it? So hopefully you remember, but many videos ago, I introduced the parallelogram and I gave you guys a wonderful definition. The definition reads that a parallelogram is a quadrilateral in which both pairs of sides are parallel. This word parallel is what we're going to focus on. So although we need to prove that ABCD is a parallelogram, most specifically, so I'm going to write right here my goal, I need to prove that this line and this line are parallel. So I need to prove that the line BC is parallel to AD. And I also need to prove the other side. So I need to prove that this line and this line are parallel. So I need to prove that BA is parallel to CD. I almost said congruent. So that is really my goal, okay? So first of all, my first statement is I'm going to write what is given to me. And that is that angle BAC is congruent to DCA. This is given. I'm going to focus on this first of all. Now, what I want you guys to remember is that shapes are made up of angles. I talked about this at the very beginning of the quadrilaterals unit. And it's also made up of lines, most specifically the transversal line. So I'm going to highlight a few lines on this parallelogram, and hopefully you will be able to see what I see. So if I highlight this line specifically and this line, I see that I have a transversal this way. Okay. And I also see that my blue angles are definitely congruent by the alternate interior angles, right? So I can also say that these are congruent by alternate interior angles. But hold up, let's think a second. Let me extend these lines, hopefully you guys can see it a little better. Let's think a second. In order to have a transversal line and its angles, we need two things. We need this transversal that's cutting through it, but we'd also need two sets of parallel lines. So by assuming that these are congruent, we are basically also giving away that these lines have to be congruent. So therefore, I can say that the line BA is congruent to CD by the converse of alternate interior angles. Now, this word converse, I'm not talking about this shoe. When we're talking about proofs, the converse, it kind of means the backwards or the assumption. So again, by saying that these angles are congruent because they're alternate interior angles, we also have to assume that they're parallel. We are basically claiming already that they're parallel. So it's kind of saying, oh, you said this, so it also follows that this means that. So we got this first definition, this first part of the definition done. Okay. But let's use our mathematical skills of patterns. So I see that when I highlighted BA and CD as part of my transversal line, we concluded that they were parallel. So I wonder what would happen if I highlight the other side of this. So let me go ahead and erase these little drawings. So now I am going to highlight this angle, this line and this line. And now this is my transversal. So now I have my reds. I can see now that this angle and this angle are congruent, right? And it's also something that's given. I am given that the angle BCA is congruent to DAC. This is given. And also because they are alternate interior angles again. So this is exactly the same as what we just covered. Because these are congruent and because we're saying that they're basically alternate interior angles, then we are also claiming that the line BC is parallel to AD. And again, we say this by using the converse of alternate interior angles. And we are done because that's what we wanted to prove, that these two lines were parallel. So I'm going to go ahead and write my statements. Again, I'm going to try using a blue for sentence frame. So I'm going to write since, and I'm actually going to connect some of these so I can write a little less. So since, I'm going to write my givens, which is this one and this one. The angle BAC is congruent to the angle DCA. And the angle BCA is congruent to DAC. Then, what did we get? We got that these two are parallel. Then the line BA is parallel to CD. And the line BC is parallel to AD. And how do we get this? We always have to explain how we got it. By the converse of alternate interior angles. But I mean, what is that really saying that they're parallel? We have to bring in the definition of a parallelogram. Therefore, and again, we have to say our claiming. Therefore, ABCD is a parallelogram by its own definition. So by its definition. So we said that since these four angles are congruent to one another, then we got that we have two sets of parallel lines. Then it's a parallelogram by its own definition. And of course, this wouldn't be complete with our done aced it symbol. And there you go. ABCD is parallelogram.